Welcome to the Thought Decoders podcast with Sean Mixon. Today I have the plum-pleasing pleasure to be on with the man, the myth, the legend, none other than Casey Luskin. And for those of you who don't know, it's Dr. Casey Luskin. Dr. Luskin, how are you doing this afternoon?
Great, Sean. It's great to be on the show with you. Really appreciate your work, and it's really an honor and a pleasure to talk to you today.
All right, it's always a pleasure and honor to speak with you as well. For those of you who know Dr. Luskin, I bet he wants me to call him Casey for the rest of this interview. So.
Yes, sir. That's right. I don't respond to doctor. I always say only my wife is allowed to call me doctor. No, that's a joke. No, but call me Casey, please.
Yeah. But Casey is known to be a passionate thinker and speaker and communicator. He thinks so quickly on his feet, and he gives some of the best presentations that you could ever see. Casey is also well-rounded in all things intelligent design and law, and so we're just excited and honored to have him on the show today to talk about some of the lines of evidence, 5 lines of evidence for intelligent design based on a recent ebook that Casey has written. So, Casey, just so we can just open up, I want to kind of better understand your background and how it is. How did you get started in all of this?
Sure. So I guess it started back when I was an undergraduate at UC San Diego, and my very first course that I took in college was titled History of the Earth and Evolution. And so I took this course, my first undergraduate level course, and I was sort of really interested in just the question of where did we come from? Is there evidence that we evolved, through Darwinian evolution and just the standard evolutionary story? How does that really interface with the evidence? So when I was an undergraduate, I took all these courses in evolution and also just biology courses. My major was earth sciences, but I really just kind of got interested in the questions of origin. So I was taking all these courses. At the end of my freshman year of college, at the end of my undergraduate year, a friend of mine said, Casey, have you heard of this book by this guy named Michael Behe called Darwin's Black Box? And I said, no, I hadn't heard of it. He said, well, you've got to read this book. So I read this book, Darwin's Black Box. And Michael Behe had put into words what my rudimentary freshman brain had been trying to sort of comprehend about evolution. I was sitting there in these courses feeling like, okay, this is interesting, but there's all this complexity in living organisms, and how does it evolve, one little mutational step at a time, as Darwin's theory requires. And when I read Darwin's Black Box, I was like, okay, this makes so much sense. You've got these irreducibly complex structures that require certain parts to be present before they can give you some selective advantage and can function. And so I really felt that Behe had just articulated what my, at that point, very limited understanding of the biology was sort of thinking through. And so from there, I started reading more and more ID books, and eventually kind of got into this dynamic during my undergraduate years, Sean, where I would be taking courses in evolution during my studies, but then on my own free time, I was reading books by, really nefarious characters like Michael Behe or William Dembski or Philip Johnson, or Jonathan Wells. And it got to the point where I was like, there's such an interesting conversation to be had here. I think other people should be able to talk about this. But my classes would never give us the opportunity to have these conversations. Maybe very, very rarely would you get a class that would actually sort of like interface with the whole evolution, intelligent design, origins question and debate. So at the end of my junior year of college, some friends and I co-founded a student club at UC San Diego called the Intelligent Design and Evolution Awareness Club, or IDEA Club for short.
Wow.
And the whole purpose of that club was to give students a chance to have these conversations that our classes were never letting us have. And we made it really clear that anybody was welcome at our little club, whether they were, an atheist or a Hindu or a Buddhist or a Christian, old Earth creationist, young Earth creationist, theistic evolutionist, ID, whatever. Everybody was welcome at our club. And we had a great group of people coming. We had undergrads, we had grad students. We even would invite occasional evolutionist faculty to come and present to us so we could learn. And we had a great time. So for me, And this was called the Idea Club, is what we called it for short. The Idea Club was really where I first got involved, I would say, sort of actively in, sort of going out and advocating for a viewpoint on this issue. The founders of the Idea Club, we were all supporters of intelligent design. We all thought it was a really good scientific idea, but we didn't feel the need to like beat people over the head with it. We were just like, hey, we just want to talk about this. We think the arguments speak for themselves, but we want to hear from other people. Maybe people have good answers, good objections, good refutations. We were just undergrads who were trying to seek truth, and it was a lot of fun. And so that was my first, how I got my feet wet on this issue. Yeah.
Okay, so what were you studying during that time? What degree were you pursuing?
Yeah, I was an earth sciences major and a history minor. But I found myself that almost every elective course I would take it something related to evolution or biology. So I ended up with, and also my history courses, I was taking like, history of science and religion, or, history of Greek and Roman thought on, the origin of the universe, stuff like that. So I was also taking all these courses that were dealing with topics like evolution, and origin of life. I took a seminar actually at UC San Diego that was taught by Stanley Miller, the famous origin of life theorist. So I got a lot of great opportunities to, learn about evolution while I was there. I just don't have a degree to show for it, but I had a lot of evolution courses. Yeah. And in addition to all my sciences. Yeah.
And had you thought about this before you entered your undergraduate work? Like when you were in high school, had you ever thought about this or?
Yeah, I mean, a little bit. I did think about it some. But for me, it was when I got to college that I thought, okay, this is my opportunity to really like figure out where I stand. Is evolution true? UC San Diego was, and I think it still is, the number one public university for biology research in the United States. It's a huge science-focused campus. And so when I got there, I was like, wow, this is an opportunity for me to learn, the real deal. Like, is evolution really accurate? So yeah, sure. I mean, I looked into it a little bit, but I would say I just kind of dabbled in the topic as a kid, an undergraduate. I actually had a lot of struggle picking a major because I had so many different interests. And this also was true of me in high school. I was taking AP chemistry and AP history and AP, computer science, because I just had a million different interests. So when I got to college, I picked earth sciences because it allowed me to study chemistry, physics, biology, and do some computer programming, all in one. And you go camping as well. Like, who wouldn't want to study a major like that? So that's why one of the reasons I picked geology. But I just had a lot of interest. But when I got into these courses on evolution, this kind of just sucked me in, and I was like, okay, this really just grabbed my intellectual curiosity, and I kind of became, a little bit obsessed with it, you could say. So yeah.
Wow, it sounds like you've always been like really smart, like just love to learn.
I mean, I was a normal kid. I was, I was a nerd. I was on the tennis team in high school. I played Little League as a kid, so, I mean, I like to learn for sure, but, Sean, I probably say the same thing about you. You're a very smart guy, so we have our intellectual interests, but we also have lives outside of that. So yeah.
Controversial, fiery, was it some epic moments in these meetings?
So, sometimes they definitely did. But normally what was cool is that we really made it a point to make sure that everybody felt welcome at our club, regardless of their personal views. In fact, that was in our mission statement, that we wanted everybody to feel comfortable and invited and welcome and warm, regardless of where they were coming from. And so what we would find is that because we had worked hard as sort of like the club leadership to build an atmosphere like that, if somebody was like having an off day, and getting a little bit feisty, the Christians would tell the fellow Christian who was like having a bad day, hey bro, you got to go cool off. Or the atheists would, who were part of the club, they would tell their fellow atheist, hey man, or whatever, like, just go take it easy and come back, So like everybody kind of like agreed with this spirit of camaraderie. And yeah, occasionally it would get a little bit feisty, but generally it was pretty cool. And I appreciated that. We had a good group of people there from different backgrounds and beliefs. We most of the time we were all very committed to having friendly conversations, even when we disagreed. And to me, that's a core value, civility. I think, obviously we can go down this rabbit hole, but we're losing that in our culture today, that people are losing the ability to have conversations in a friendly and civil way, even when they disagree. But for me, that's always been a real core value. And, I'm not perfect. I make mistakes sometimes, but I do try to live that out because I just think it's like one of the most important things is to be able to talk to people and have a friendly conversation, even when they don't maybe think the same way you do.
Okay. Yeah, you're right about that. We're losing the ability to agree to disagree. I've heard that my entire life, but what it shows is that even when you disagree, there's a certain level of agreement, and that's what civility is. It's like although we disagree, there are things we agree about, like the respect for one another, your dignity in spite of your beliefs. Today we measure we measure the dignity of a person in terms of whether or not we agree with their beliefs. So if your beliefs aren't right, then there goes your value. So I think that there was wisdom in this common saying, let's agree to disagree. But I thought about how much of the different objections and things that you heard during this group, how much of that kind of really prepared you for the objections that you've heard and experienced and handled since then? Did that kind of help you out today, or do you still in many ways kind of deal with the same kinds of objections, or how does that interact?
Yeah, by the way, before I answer, I just want to say that was super well put what you just said about civility and how even when you agree to disagree, you can do that because you kind of have common values that like our humanity is more important than agreeing upon everything. In my family growing up, holidays, people were all over the map on things, and that was okay. Like we all loved each other, and it's still like that to this day. And I think that it's sad that that is sort of leaving our society a little bit. Anyway, you said it really well. I'm not going to try to say it as well as you did, but I think you hit the nail on the head there. But yeah, getting back to your question, yeah, absolutely. I mean, it's funny how the more things change, the more things stay the same. We were hearing people objecting to us with junk DNA and pseudogenes, even back in the late 90s and early 2000s when I was a part of the Idea Club. Or we would hear about, co-option as an answer to irreducible complexity and the type 3 secretory system. Or we would hear people talking about the multiverse, there's not really fine tuning. There's dependencies between the parameters. And so you can kind of explain things. They're not independent, blah, blah, blah. There's so many different objections that they've been around for a long time, actually.
Mm.
I think that the answers to these objections, one of the things that has encouraged me, and we can get into this more if you want, is that, some of these objections back, say, 20 years, something or so years ago, when I would hear, like, say, the junk DNA objection, well, at that time, we knew so little about the genome that we didn't know that the vast majority of the genome showed evidence of biochemical functionality. Whereas today, the answer to the junk DNA objection is, well, no, it's just we know that it's not right. Like the vast majority of the genome is biochemically active and it has some form of a function. But back then, nobody knew what it was doing. And so, I think that I've been very encouraged over my time of watching this debate because I feel like so much of the evidence has just come more and more on the side of intelligent design. And when you get that long perspective, it really gives you confidence. Hey, I think we're onto something here with ID because over time, our arguments have been vindicated over and over again
Wow.
as the data comes out. So yeah, for sure.
Wow, that's definitely exciting. Uh, Tell us a little bit about like what you've done. So you went on, as I understand, to complete a Juris Doctoris, a JD, Doctor of Law, and then you have a PhD in geology as well. Tell us how those educational experiences inform the work that you do today.
Sure. So when I got my JD, when I went to law school, my plan was to actually do environmental law, Sean. And when I finished my undergrad and master's degree from UC San Diego, and when I was finishing my master's, I realized, wow, like in a few months, I'm going to be out with a master's degree in earth sciences, which is cool. But what could I do with that? Well, there's things you could do. I mean, I could go get hired by some oil company and dig for oil in the desert or something. That just didn't appeal to me. And I always, I like using the right brain, but I also like using the left brain, or whichever, maybe it's the other way around. I wanted to use the other side of the brain, basically, to not just do science. And I loved writing, I loved rhetoric, I loved reasoning, and through the idea club, just the structure of making a good argument, a valid form of logic. You're a philosopher, so you know far more about that than I do. But so when I went to law school, I just wanted to kind of hone my rhetorical, writing, reasoning skills, and I thought I was going to do environmental law. I thought I would combine the law degree with earth sciences, and living in California, there's a huge number of jobs in the field of environmental law, and that was my plan. And I even was doing a clerkship with an environmental law firm in San Diego and Southern California. And I thought that, I was probably going to go and work in that field. And then a couple months before I graduated from law school, I'd gotten to know some of the folks at Discovery Institute through my work with the Idea Club, which by then it had actually turned into a nonprofit, a 501c3 called the Idea Center. And we had helped students to start idea clubs all around the U.S.
Wow.
By the time I graduated from law school, it was actually to become an international movement. And a couple months before I graduated, we made the cover of Nature. Nature actually wrote a cover story about intelligent design, and they largely focused on the Idea Club movement. It was crazy. Like, we were blown away to get this kind of attention. But right before I graduated, I got contacted by some folks at Discovery. They had a staff attorney who had been offered a really wonderful position to clerk for the Washington State Supreme Court. And they were looking for a new, young attorney to go around and travel around and basically talk to teachers and educators and policymakers on how to teach the topic of evolution in schools in a way that was both legal and scientifically accurate. And so I had done a lot of studying during my law degree of evolution education. I actually did an independent study on the constitutionality of teaching the whole issue. Took a course from Edward Larson, of course, a wonderful law professor, author of Summer for the Gods, and I took some other courses in education law. So I kind of knew this issue a bit, and had done quite a bit of study on it. So I was really excited to go and take a job at Discovery. And, I was kind of like, I couldn't believe somebody was paying me when I first started my job. This was in around September of 2005, to actually talk to teachers about how to teach evolution accurately and legally. And this is just like my dream job. I was using both my science and my law, and I loved it. So for my first 5 or so years at Discovery, I would say, probably like 70% of my job was law focused, advising educators on the best way to teach the issue, also getting involved with a lot of academic freedom issues. One of my first assignments, Sean, was to actually fly out to central Pennsylvania and observe the Kitzmiller versus Dover case. We were not a party to that case, but I sat there in the courtroom and watched, Ken Miller testify, and watched, various other folks testify, and was reporting on that for Discovery Institute, and sort of trying to help us. We also submitted some amicus briefs in that case, friend of the court briefs, encouraging the judge to not rule that ID is a form of religion. And he basically ignored everything that we gave him. That's my opinion, at least, because we gave him evidence of peer-reviewed papers, which he then later ruled didn't exist. So I don't know how that works. But anyway, long story short is that was a lot of fun, but I got involved with quite a few academic freedom cases. So it's well known that ID proponents, unfortunately, do often face persecution in the academy. And so a lot of scientists and academics, especially after the Kitzmiller versus Dover ruling, there was sort of a national witch hunt that was inspired by that ruling to hound ID-friendly academics, especially scientists, out of academia. And so I call those years, say like 2005 to 2010-ish, kind of the post-Dover purge. And it was not fun because we saw a lot of really good people who were getting persecuted and sort of discriminated against. And that's why in 2008, you had the movie Expelled that came out with Ben Stein, where he told the stories of quite a few of these scientists who had been discriminated against. And that was largely in the wake of this intolerance that was these flames of intolerance that were fanned by the Dover ruling. So, but then in 2011, I had a bit of a job shift at Discovery. I don't know if you want to know all this. This is just my life story, I guess, here. But I shifted to a more science-focused position, research coordinator, and I actually really welcomed that because science has always been my true passion on this issue, Sean. I've always believed that, intelligent design is going to rise or fall on the science. It's never going to be won by legal debates or court cases. Those can be very landmark sort of moments in culturally in the evolution debate. For sure, I think history shows that court cases can be landmark moments. But at the end of the day, ID is either going to make it or not make it based upon the science. And so the science has always been my passion. So in 2011, I had a more science-focused role at Discovery, and which I was very happy with, and ended up being Steve Meyer's research assistant on the book Darwin's Doubt. And that was a lot of fun.
Oh, wow.
Got to co-write an ID textbook, Discovering Intelligent Design, contributed to a number of other ID-related books, science-related books, Science and Human Origins, our response to the Cosmos book, and a few other books. So had a great time doing that. But then kind of was just feeling the need to go back to school. So in 2015, at the end of 2015, I left Discovery and went and started a PhD in geology at the University of Johannesburg. And this is sort of a long-time dream of mine to go back and get a PhD. Obviously, had to get my wife on board with that because we moved to South Africa. But thankfully, her family actually originally is from South Africa, so we have a lot. This was one of the big reasons why we went there. In addition to the fact that they have great geology research in South Africa with all the mining industry there, just wonderful, wonderful geology research in South Africa. So we moved to South Africa at the end of 2015 and started the PhD and kind of took, not 100% hiatus, but very much a break from intelligent design. But really enjoyed studying geology while I was there, and we can talk about that more if you want. But finished that in 2020, and then came back to the U.S. and came back to Discovery. So yeah.
Yeah, so that establishes your credibility in the fields that you're working in. Absolutely. Want to kind of transition into talking about more specifically of the content of evolution and intelligent design. What is the evolutionary theory? When I hear evolution, it's used in several different ways. But in terms of what you've learned from your coursework and study, what is evolution? What is the theory of evolution?
Sure. So, I mean, we often like to say that there are different ways you can define evolution. And some of those definitions are very non-controversial, and some of them are very controversial scientifically and also, I think, philosophically and theologically. So certainly a very benign definition of evolution that I don't think anybody disagrees with is just the idea of change over time. Yes, there's change that goes on within species. The strict definition is, change in allele frequencies within a population. That's the strict definition of evolution. It just means that, some genes are becoming more prevalent than others within a population, and that's typically due to forces like natural selection, where some individuals within a population are better suited to survive and reproduce under their environmental conditions than others. And so then they tend to leave more offspring and the species will evolve in their direction. There, of course, are other factors that can affect, how species change. Genetic drift is sort of just a stochastic process, which says that sometimes, some individuals get lucky and they tend to mate and leave more offspring and their genes get passed on, and others, the tree falls on the rabbit. Maybe he may have been very good at surviving, reproducing, but he had a bad day and didn't make it, and his genes didn't get passed on. So there are random factors as well that influence how species evolve. But so that's sort of just the idea that species can change over time. I mean, I think nobody disagrees with this. All right, every time a baby is born, technically speaking, the human species has evolved. All right, fine. And you can have, small scale adaptations. Going back to rabbits, a species of rabbit that lives in a climate that's becoming colder and colder and getting more and more snow. Well, they might shift towards lighter colored fur, so there's more camouflage, and you get these, snow colored rabbits. There you go. Okay, so these kinds of small scale evolutionary changes, what we might say microevolution, certainly these things happen, and these kind of changes do occur. Another definition of evolution would be common ancestry. The idea that all living species are related. If you go back far enough, everybody is not just related. All humans are related, but we're related to our pet cats and dogs. And then go back even further, you're related to the tree in your front yard. Go back even further, you're related to the bacteria that are swimming around in your gut. So basically all living species, all living things are related if you go back far enough through descent with modification. And that is sort of a core concept of evolution. And so then the question becomes, what is the mechanism of that descent with modification? Well, again, according to the modern neo-Darwinian model of evolution, which I think is sort of the standard evolutionary model, the main driving mechanism of evolution is natural selection. It's a blind process that happens on its own without any external guidance or divine oversight or intelligent guidance, anything like that. It's just that, those individuals which are better able to survive and reproduce will leave more offspring. That's all
Can
it
I ask you
means.
something? So natural selection, is that an oxymoron?
I don't think it's an oxymoron, but I mean, nature does not, strictly speaking, select. I mean, it's sort of an anthropomorphization of nature, and a lot of people have been critical of the term natural selection because nature can't actually think, right? It's not
Right. So it's
intelligently.
like,
Yeah.
yeah, it seems as though what you want to do with the word natural selection is take away the idea that there is some intelligent design, right, or planning, right? But if you include the idea of selection, then you have to have something that is aware of options, something that selects, and to select means to not choose certain options and to select one option. So like each choice that you make, there is something that you're not choosing.
No,
And it.
you're right. What you're saying right now is absolutely right. Um, Natural selection is supposed to happen on its own. There's no thought to it. There's no mind behind it. Darwin has this great quote where he said, "There seems to be no more design in the variability of organic beings and in the action of natural selection than in the course which the wind blows. Everything in nature is the result of fixed laws." So that's basically Darwin's view. It's just
Right.
a natural, blind, unintelligent, directionless, doesn't care about you one bit. If you're good at surviving and reproducing, you will leave more offspring, and that's just how. And if you're not, then you won't. And that's just how it works.
Right. So it seems like it's misleading. The name natural selection is misleading. It seems like what it's really pointing to is just accident, natural accident. That would seem to be it's just an accident of the place, the time, circumstances. It's just chance. It's just
Well, it's accident in the sense that it wasn't planned. Okay, they would certainly say it was not planned by any intelligent agent. That's the standard evolutionary view. However,
mm-hmm.
they would push back on the idea that natural selection is chance, because they would say, look, you put a bunch of organisms in an environment, and if those that can run, if the cheetahs that can run faster have a 10% better chance at surviving and reproducing and catching more gazelles, then they're going to leave more offspring. So they would attribute that to a law-like process. And they would say, within natural mechanisms, you can have chance and you can have law and you can have a combination of the two. And so the way that the modern neo-Darwinian model or the standard evolutionary model today works is mutations occur randomly. And so they are random. Mutations definitely are occurring a chance. That's according to the theory, at least, without respect to the needs of the organism. But then what actually gets preserved is non-random, because those features which help an organism to survive, you can predict in a non-random manner that they're going to tend to be preserved more often than those individuals that don't have that trait. So they would, but in the sense when you say accident, like it wasn't planned, certainly they would say it wasn't planned, and they would also say that there's randomness in the evolutionary process. Mutations are random. Okay, so if a feature does not arise, natural selection cannot preserve a feature that never arises, and features only arise due to mutation. So there is definitely an element of randomness in the origin of the features that natural selection has to choose from, quote unquote. It has to select from. So there's an element of randomness. There's also randomness, as I mentioned earlier, in genetic drift or stochastic processes, we might say, because you might be the fastest cheetah, in the flock. But if let's say that a meteorite falls out of the sky and hits you one day, well, bad luck, buddy. I'm really sorry, but you don't get to pass on your genes. Or something more likely could be that you're the fastest cheetah in the flock, or you've got the genes to be the fastest cheetah in the flock. But maybe when you're 2 months old, your mom gets eaten and you're defenseless, and then you get eaten. And so even though you had good genes, you don't actually get to make it. So there's a lot of according to this is where there's a whole debate in evolutionary biology. It's a long-standing debate. Is everything we see the result of adaptation, natural selection, or is it the result of drift, neutral evolutionary processes? And I think most folks would say that it's a combination of both. You have both random processes and you have natural selection going on, and together you get evolution.
So I hear you have the mutations of the DNA, which affects the organism. It may or may not make the organism a better fit for its environment. But if it does, then those features, if passed on, are more likely to help the offspring to survive. But the stochastic view is that even if the offspring survives, but it's eaten, happen to be eaten by a bear, and it's like, well, there goes those.
Stuff happens.
Yeah, stuff happens. So, what originally was the theory of natural selection created to explain? Like, what was Darwin trying to explain with the theory?
No, that's a great question. Definitely Darwin saw natural selection as a designer substitute, okay? So Darwin came around, a few decades after Paley, right? Paley had made this case that the complexity of living organisms, you have a watch, you need a watchmaker. The complexity of living organisms points to the need for a mind that can organize all this complexity and order that we see in living organisms. Darwin wanted to try to explain that order without appeal to a mind. Okay. And so that really was what natural selection was conceived of, was a way to explain, these features of organisms that seem so good at helping them to survive and to make it in the world. And he wanted to explain that without appealing to an intelligent cause through a natural process. And that is why natural selection became so popular. It was sort of like the heyday of, we can explain all of nature through purely natural mechanisms without any recourse to a designer, a creator, a divine being, God, whatever. We don't need that. It can all be done through natural mechanisms. And Darwin, when he finally explained living organisms, or people thought he explained it, they were like, okay, if we can explain living organisms through this, then the whole show is done. We can do everything with just no design whatsoever.
So Paley, I'm glad you said that, because Paley, in his work Natural Theology, chapter 1, State of the Argument, I'll read a quote from it. So Paley asked if we're walking through a forest or some type of grove, and we tripped over a stone, and someone asked us, how long has that stone been there? Paley said that you may say, for all you knew, the stone had lain there forever, or been there forever. So he said, however, but if you were walking through a grovey area and you tripped over a watch, if someone asked you how long had the watch been there, he said you wouldn't say forever. He was pushing on some of our intuitions, and so the question I asked my students in my Intro to Philosophy class is this. I say, can nature make a watch? Their first initial response is no. But when I tell them, I say, well, if nature can't make a watch, and human beings are more complex than a watch, then why think that nature can make make human beings, and then you know what they end up saying? They end up saying, "Oh well, nature can make a watch." And so Paley says that Paley says this. He says, "Why? Yet they? Why should you not answer the? Yet why should not this answer serve for the watch as well as for the stone? Why is it not as admissible in the second case as in the first? For this reason and for no other, that when we come to inspect the watch, we perceive what we could not discover in the stone, that its several parts are framed and put together for a purpose. For example, that they are so formed and adjusted as to produce motion, and that motion so regulated as to point out the hour of the day, that if the different parts had been differently shaped from what they are, of a different size from what they are, or placed after any other manner, or in any other order than that in which they are placed, either no motion at all would have been carried on in the machine, or none which would have answered the use that is now served by it. When I read that, and I just reflected on Dembski's work, how when you think about a watch, the time on a watch is independent. It is independent. The meaning of the numbers on the watch is independent from the shape of the watches. And so I was like, wait a minute, this Paley saw this at the very beginning. And then I also thought about Michael Behe, irreducible complexity. He says if you change any of the parts, it won't have the function. And I was like, wait a minute, that's irreducible complexity. So I see a lot of these intelligent design ideas that are they go far back. I mean, even before Darwin's theory of evolution, in a sense. And so I guess Darwin would need to explain why the parts of our systems are arranged, so to speak, in order to have a function. Does evolution explain that? Or do they attempt to explain it? Or how do they explain it? Because saying that, well, you have this mutation, and the mutation creates a certain change in our body systems. Well, you're already presupposing that there are these systems and things like that. So shouldn't he be able to explain how, like the origin of life, to explain how it developed from the first life?
Yeah. So first of all, you're absolutely right that intelligent design goes way back before Darwin. It even goes way back before Paley. I mean, sometimes our critics like to say, oh, ID started with Paley because Paley was all about natural theology, not realizing that natural theology is actually not based upon religion, it's based upon nature. But, intelligent design goes way back before Paley. You can trace ID arguments back to Plato, okay? People that had nothing to do with sort of, the Judeo-Christian, they were non-Judeo-Christian pagans who were arguing for intelligent design. And some of the greatest philosophers of Western civilization were making proto-intelligent design type arguments. But we can do that another time. So getting to your point about Darwin has this really famous quote in Origin of Species, where he says, he basically is laying out a test where he's acknowledging that there are ways to refute his theory. And I think that Paley's arguments, I don't know if they directly influence this quote, but you can certainly see how they fit together. He says, if it can be demonstrated that any complex organ existed, which could not possibly have been formed by numerous successive slight modifications, my theory would absolutely break down. Now, Darwin said he could find no such example of such an organ which couldn't be built in this way. But I think that what he's giving a sort of a nod to here is that when you have these complex systems, that require lots of parts in order for them to work. Maybe in Darwin's day they didn't have cell phones or mousetraps, but they certainly had wagons, or they had wheels, or they had rudimentary machines. And I think that there was an awareness here that some structures require a certain core number of parts before they work. And this really is also a precursor to Michael Behe, as you said. And Paley was sort of, I think, Behe is following in this same tradition of Darwin and Paley recognizing that there can be features where you've got to have certain complexity present or they don't work. And you can't, but those things have a purposeful arrangement of parts, as Michael Behe likes to say. And I think he's right about that. When you see this purposeful arrangement of parts, you see a certain, core number of parts that have to be present. And they're sort of like, they're arranged in a way that is directed towards a goal, towards an end function. And they're arranged not sort of in just we built this up over time. No, they were put all there together for a purpose to fulfill this purposeful function in the end. That right there is a hallmark of design. And I think Paley saw that. I think Darwin saw that when he laid out his test for his theory. And Darwin didn't think we could find it. But then again, in Darwin's day, and this was no fault of his own, he didn't have any idea about the complexity of the cell that we have today. And so clearly, Michael Behe would say that as we've opened up Darwin's black box, the black box being the cell, we've begun to understand all these molecular machines which are running around inside of our cells. We're finding that there's all these structures in our microbiology, in our molecular biology, that basically could not evolve in a step-by-step manner, as Darwin said, and that you have to have lots of complexity present for these features to be able to function. And so Michael Behe would say that, as we've understood the complexity of the cell, we have met Darwin's challenge, and we've actually reaffirmed this idea of Paley that, you have parts that are organized towards an end, towards a purpose, and this is pointing to design.
Right. What's interesting is that my students often, so I do this experiment where we tried a thought experiment where we try to figure out how nature could create a watch, a mechanical watch. And I said, so how do you all think it could be done? And I said, well, maybe some volcano, some steel would fall to the ground and it would be heat up by lava. And so I explained this complex scenario and how giant rocks would fall off the top of the volcano and hit the metal in the right place to bend it into a round shape. And so I said, imagine you're watching this. Would you think would you think that this is a natural process? You don't see any person doing it. It's just random events just coming together at the same time. Do you think that this is they all said no, that's magic. It's magic. And it's because not only do the parts need to be, like as my students point out, not only do the parts need to be perfectly fitted for each other, you need something to put the parts together. That's what my students say. You need something to put it together. And just because you have the part, that doesn't mean you know how to put it together. So what is the mechanism of bringing all of these parts together? So that's interesting.
On that note, Jim Tour gives the example of you could have all the ingredients you need for a cake in your kitchen. All right. Does that mean you're going to get a cake? No, you got to follow that recipe. And that recipe is an intelligently guided series of steps to put things together in the right order, in the right way, to be able to get your cake, all right, or get your cookies or whatever it is you want to make. So absolutely, you made a great point. It's not just about having all the parts available. You also have to assemble them in the right way. And Michael Behe makes this point as well. And this is a paradox, actually, for origin of life theorists. You could take a cell and have all the parts of the cell present. You could take a living cell and you pop its membrane and all the, its internal components spill out. Well, you're never going to have a cell reassemble. That thing is dead. You've got to have so much organization and order to put a living structure, a living system together. It does not happen by chance.
Mm-hmm. And so I saw a debate between it was Michael Behe and the Peaceful Science guy who runs
Joshua Swamidass.
And Swamidass mentioned in his argument or his response to Michael Behe's approach, he mentioned co-option, the co-option of parts, and so the function. In other words, so this is my understanding of co-option. You have a watch, and all of its parts work together, and the ultimate function is for the hand to tell time, the hands to move around. Co-option seems to be the idea that, well, you can keep the same parts to create a different function overall. Right? So, like, the pieces could have had a different function. What is the response? Like, first of all, how does that relate to evolution? Is the idea that, we had eyeballs, but they served as things we can scratch our arms with? Like, what's the how does that relate to the discussion?
Sure. So, the co-option objection has been around for a long time. This goes back, we're talking about, things that I heard at the old Idea Club. We would hear about the objection of co-option as an answer to irreducible complexity. So irreducible complexity kind of assumes that if you're going to build some structure, you're building it with a particular function in mind that you want to fulfill. And so it can't evolve by Darwinian evolution because that function does not appear until you get a certain core number of parts present, okay? So there's no reason for natural selection to preserve those parts before that there's sort of a minimal number of parts there to give you that function, and that function can now be selected for, okay? It can do its thing, it can be selected for. So what co-option says is, well, maybe those parts didn't originate for this particular function. Maybe they originated for some other function. And that's why the parts were all present in the cell or in the organism. They started off for something else, okay? There's a bunch of different names that are used for this idea of co-option, but the idea is basically that, parts can be borrowed, tweaked, retooled, co-opted to then do a new function in the cell as a part of another system, okay? Gosh, I'm sorry, I hear my cat in my background begging me to go feed him dinner, but he's got dinner. I don't know why he's complaining so much right now. I already fed him, so he should.
I can't hear.
I don't know what his problem is. No problem. Anyway, so there's a bunch of different names for this concept. Some people have called it pre-adaptation, okay? And folks have used pre-adaptation to explain the origin of feathers. Maybe feathers in dinosaurs, they would say, originally did not evolve for flight, but for insulation. And it just happened that they were.
Why do they need to explain the origin of feathers?
Well, if you're an evolutionist, you got to explain the origin of everything. Everything requires explanation. So, according, if you are a typical evolutionist, then you want to explain how things arose, where they came from. So feathers seem so well adapted to flight. How can you get a feather that is not, got all these special properties and special design parameters? The zipper, the shape, the lightweight, the very strong shape of it, etc. How can you get it? And so they will say that maybe originally feathers evolved for insulation rather than for flight. And so they would say that feathers were pre-adapted. Another name for this argument is called exaptation. Rather than adaptation, it's exaptation, where it was originally evolved for one function, and then it was sort of co-opted, retooled, and deployed to do some new function in biology. And so
so
go ahead.
Let me interrupt you there. So it seems as though that is a response to an ID claim where it's based on agreement. Like there's like, so what is it that they're agreeing with from the ID theorists?
Well,
where's the agreement? Because it seems like they're saying, well, yes, but the way we explain that. So what is it? Is it like, look at all these parts that are here? How do we explain the presence of parts that fit so well together? How do you explain that piecemeal? Or
no, your intuitions are very good, Sean. In a sense, the co-option rejoinder implicitly concedes that yes, to get this particular function, let's talk about the bacterial flagellum, okay? To get the spinning, swimming function of the bacterial flagellum, it's going to require a bunch of parts. Okay, you can't just build it up You can't have one protein that's giving you the swimming function.
Mm.
You can't build it up one step at a time. You need multiple proteins there. So then what they will say is that maybe the flagellum evolved because you had multiple components from other systems that suddenly magically got retooled to be able to fit together to perform an entirely new function.
Wow.
You had one system that forms sort of the basal body that anchors the flagellum in the cell, and another system that had like something that was kind of long, and then it was able to suddenly perform a spinning function. And then you got the motor that was borrowed from some other place in the cell so that it could twirl everything around. Okay, so basically you've got all these machines that were doing other things in the cell, and then suddenly those machines were tweaked and retooled and co-opted and then redeployed so they could fit together and interface with each other and perform an entirely new function. There's this great
So
quote.
that's just kicking the can
Well,
down the road.
there's this great quote by William Dembski and Jonathan Witt. This is what they say. They say, "What is the one thing in our experience that co-ops irreducibly complex machines and uses their parts to build a new, more intricate machine? Intelligent agents." Okay, and I think that says it all. But look,
Wow.
let me give you some other answers to co-option really quick, because this is an objection we've heard for a long time. One of the problems with co-option is that a lot of times we find that proteins or biological parts are unique and we don't see them available to be borrowed from other systems. Okay, so we get a lot of unique proteins. We call them sometimes orphan genes, or just parts that don't show homology, to other systems within the world of biology. So a lot of times, we don't see that parts can actually be co-opted. Second, they will then say, well, we found sequence homology between this protein and another protein. And that just means similar amino acid sequence between protein A and protein B. That means that maybe protein A could have been co-opted from something like protein B in the past to then fulfill its function in the cell. And the problem is that
wait a minute. What is sequence?
It means when you have a similar sequence of amino acids between two proteins. Okay,
like taking the acids and ordering them, like each acid is an alphabet, A, B, B, that kind of thing.
Exactly. You got all these different amino acids that are found in living organisms. So, maybe you find a similar sequence of amino acids, histidine, valine, lysine, phenylalanine. Okay, well, you see those 4 amino acids in the same order in protein A, and then you find that same sequence in that same order in protein B. And maybe that is, showing these amino acids share common ancestry, and therefore, protein A might have been co-opted from something like protein B in the past. Okay, and
so they assume common ancestry to prove it.
Well, I would say common ancestry could explain the similarities, but so could common design. Because you can also get similarities due to designing parts for similar purposes. We do that all the time. When people design a new version of Windows, they use previous versions of Windows to form sort of the blueprint for the new version. So designers will reuse parts that work all the time. But
why reinvent the wheel?
Why reinvent the wheel? Exactly.
Yeah.
But when they're finding sequence similarity, at best, what that is showing is common ancestry. That does not demonstrate a step-by-step evolutionary explanation. Okay, it's just not enough to demonstrate that. Third, it's not easy to just co-opt a part and suddenly use it in a new system. And in fact, there is some ID research that has been done trying to take a protein and convert it through random mutation to perform a function of a very closely related, very similar protein. And what we've shown is that it takes a lot of mutations to be able to do that. And it's not clear that you almost run into another irreducibly complex kind of scenario where you need lots of mutations to be able to convert protein A to be able to perform the function of protein B. It's not easy to do these evolutionary conversions. Many mutations are needed, probably more than.
And you not only need mutations, you need mutations that are beneficiary, correct?
Yes, and often what ends up happening
that are not destructive.
Yeah, before you get the new function, you often end up sort of in like this no man land where the protein is actually not providing you with any useful function. And then you're just relying upon what's called random drift to get from protein A's function to protein B's function. It's not clear that you can actually find a stepwise path in many cases that gives you an advantage with each successive mutation. So that's a problem. That evolution basically gets stuck at that point. And then even if you could somehow retool, tweak protein A to do the function of protein B, you still have to explain the assembly instructions. Suddenly you're getting all these parts coming together to form this irreducibly complex system. And when that happens, it's starting to look very teleological, right? So these co-option scenarios, which never really have much detail, I mean, all they really ever cite is just amino acid sequence similarity, which we often call homology, which is not enough to justify a co-option explanation. But even if you did, if it actually works, which I've never seen when it actually works, they start to look astoundingly theological. Okay, so I would argue you end up sort of like with this catch-22, where if a co-option explanation actually is working, it's looking very teleological, where the initial state, all these different machines that could be pre-adapted to perform a new function, it looks like they were kind of set up and designed to do that. But if they don't have that sort of teleological feel to it, then it seems like you really can't get the job done, and they're not similar enough to actually get the co-option mechanism to work through successive slight modifications. So anyway, that's sort of the catch-22 that I think co-option faces. Bottom line is that I've never seen a step-by-step, compelling co-option explanation ever provided for anything. It's just sort of like hand-waving, and it never actually gets down to any detail that you can actually test or even say, oh, well, this could be wrong.
Right. So it seems to me it's like the can't kick the can down the road fallacy, where in order to explain one system, you assert that there's another system, and from this system, we get the parts for a ladder system. But now you need to explain, how did you get the previous system that worked with all of its parts to produce that function? So it doesn't. It's like, you see what I mean? It seems like it doesn't seem to answer. It seems like to create another problem. It's like, no, they came from this system.
Exactly. It creates a lot of problems, and you never get any level of detail. So you're definitely, your intuitions are dead on here again. Yeah.
Okay. And so I guess since we've talked about what evolution is, and I understood you to be saying that Darwin was more reactionary to try to see if he can explain life in a way which did not include design. And one way he thought to do that was to say, basically he presupposed a lot. Like, he just started in the middle of, like, he assumed that things that he assumed that there are already these systems, right? That because living things seem to be complex in the sense that they have multiple systems. Like, even in our body, we have the respiratory system, the digestive system, we have systems within systems and systems in cells, and so he just started with the systems, which are the living things, and asserted that this system can make a copy of itself, and that's an offspring. And within the transference of this system making a copy of itself, maybe some of the, just to use a metaphor, some of the coding of the programming gets mutated. And so now the copy is not an exact copy, but some things change. And then over time, that's how we get the diversity of life. I've heard it said that he was attempting to explain the diversity of life rather than the origin of life.
That is correct. Darwin's theory is not intended to explain the origin of life. Darwin occasionally made comments about maybe life started in some warm little pond, but that was definitely not the aim of his theory. Yeah, I would say that origin of life thinking kind of got started in the early 1900s, 1920s with Alexander Oparin and JBS Haldane coming up with sort of this primordial soup hypothesis. And that was when origin of life theory started to look something like its modern form, I guess. But yeah, Darwin just wanted to explain how new species arise. That was really the main thrust, how you get the diversity of life and how you can build, many of the complex features. But explaining the first organism, he didn't do.
We went
Yeah.
to some, which is any closing thought in the podcast?
No, great conversation, Sean. I always appreciate your. I make it a rule to not debate with philosophers. So I try not to say anything that you would disagree with, because I don't debate with philosophers, and I think that your intuitions are usually dead on. So it's great to have these conversations with you. Thank you.
Oh, that's awesome. Well, again, thank you again, Casey, for coming on. It's been a plum pleasing pleasure. It's been awesome. And thank you all for watching. And always remember to think better.